Let's talk about fractions. This is the first of 3 videos covering the topic, and we'll begin with the concept of reducing. Let's say you have the fraction 1 over 2, also known as 1/2. The number on the top of this fraction, the 1 in this case, is what we call the numerator, while the number on the bottom, the 2, is known as the denominator. Now, it's important to remember that a fraction is just a number, and we can visualize this number using something of a pie chart. Because the denominator is 2, I'm going to cut this pie into 2 equal pieces, and because the numerator is 1, I'm going to shade in 1 of those pieces. So we can say that 1 out of 2 pieces here are white. 1 out of 2. Hopefully it's clear how this fraction represents this scenario. Now, what if we have the fraction 4 over 8, or 4/8? Well, we can represent this the same way. In this case, we'll cut the pie into 8 equal pieces, and shade in 4 of those pieces. Now, what do you notice about these 2 pies? It looks to me like they both have the same amount of shaded area, so we can say that those 2 pies are equal. And if the pies are equal, that means that the fractions which they represent are also equal. These are what are known as equivalent fractions, with the 1/2 being the most reduced version of the fraction, meaning that it's been written with the smallest whole numbers possible. We call this being reduced to lowest terms. Now, what if you have the fraction 4 over 12, or 4/12? I can represent this again with pi, and I can start by cutting it into 12 equal pieces. Next, I'll shade in just 4 of those pieces with white. But I'm also going to highlight something else here. We have these other 2 groups of 4 pieces as well, and because all 3 of these groups have the same number of pieces in each, we can simplify our drawing to look like this. Now, looking at this simplified diagram, I could say that a fraction representing the number of white pieces out of the total pie would be 1/3, or 1 out of 3, because 1 out of the 3 pieces here are white. What we've just done is reduced the fraction 4 over 12 to its lowest terms, 1 over 3. This is reducing, and we don't always have to use the pie graphics to complete this process. Instead, what we can do is find the greatest common factor, or GCF, between the numbers 4 and 12. And I'll start by listing the factors of 4. We have 1, 2, and 4. If you're confused, these factors are just the numbers that we can wholly divide out of 4. In other words, they all fit into 4 a whole number of times. Okay, now what about 12? Well, 12 has the factors 1, 2, 3, 4, 6, and 12. Now we have to select the greatest common factor, so the largest number that appears in both these sets of numbers. It should be obvious now that our greatest common factor will be 4. Now, we want to write our fraction so that each number is shown as being 4, our GCF, multiplied by some other number. So in the numerator, we'll have 4 times 1, and in the denominator, we'll have 4 times 3. Next, 4 divided by 4 gives you a value of 1, so these 4's will cancel one another out, and we'll be left with 1/3. And that's how you reduce fractions. Now, if that seems like a long process, that's okay. You don't have to stretch it out each time. I'm just doing this to explain what's really happening. Soon, you'll be able to do it much more quickly. Let's do another example. Say we have 5 over 30, and we want to reduce this fraction. What are all the factors of 5? Well, 1 and 5. After all, 5 is a prime number. And the factors of 30 should include 1, 2, 3, 5, 6, 10, 15, and 30. The largest number from each of these lists is, of course, 5, so that's our greatest common factor. Now, once you knew that 5 only had the factors 1 and 5, you could have just checked to see if 5 was a factor of 30, and once you realized that it was, you wouldn't need to come up with all these other factors. But again, I'm showing you everything here. Now, an expedited version of this next step could look something like this. Simply divide the numbers on the top and bottom, numerator and denominator, by the greatest common factor, 5. and you'll get the reduced fraction of 1 over 6. Now, if you have a calculator and wish to check your answer, you could divide both of these numbers, because after all, you can always divide the numbers in a fraction. If you do so here, you'll see that you get the same answer for both fractions because yes, they are equivalent. Here are some practice questions for you to try. Pause the video now and give them a go, otherwise the answers will be revealed in 3 seconds. This has been Reducing Fractions. Be sure to watch the next video where we take a look at switching between the different forms of fractions. And if you have a handle on that, check out the fraction operation video where we add, subtract, multiply, and divide fractions by one another. Like or even subscribe to the channel if this video was helpful, and check out some of my other over 100 videos covering various topics of high school mathematics. And of course, thanks for watching.